Hello friends, this is Shubham and welcome to my YouTube channel. So today in this video we'll be exploring an awesome library cum application with which will be able to track deep learning models like its performances, like accuracy, loss and line, like dynamic loss and accuracy plots. That is for like each and every epochs you can see how your accuracy is decreasing or increasing, and also the loss part of it. So yeah, we'll be using this awesome library called Tensordash. It also comes with an Android application. Currently I don't know about iOS since I don't have iOS mobile, and yeah, I'll show you this demo on Android itself. Okay, so yeah, firstly you have to install this package in your in your system. That is, you're having Mac or Windows, it doesn't matter. So just do a pip install Tensordash. So I will show you all the installation steps, but before that we also want to know that what makes this package unique. So we all know that deep learning models are data hungry, and since a lot of weights and parameters needs to be updated at every epoch, and when we run it on huge data set on like several of epochs, like thousands to thousand, like not every time, but will be according to a data set we manipulate these epochs. Okay, and it will take a massive amount of time, I must tell you. So it is also not possible for us to sit next to a computer and watch our favorite model train, right? So this Tensordash application, this solves this problem, and we can do other important tasks as well while our models get trained, and also we can monitor our models performances on our Tensordash uh, Android application. So let me show you the Android application here. So here is the screen mirroring of my mobile phone, my Android phone actually. So here are the two models that I have trained, like in an example, Tensordash example. Okay, so you can see here I have run this for 30 epochs. We are getting an accuracy of 85% and a loss of 0.34. Okay, and we can see the status as completed. If you run this application, then you will see this status as running. So if we go inside this Tensordash application, we can see all its loss chart, its accuracy charts on validation as well as train data. This is the validation chart, validation loss chart, validation accuracy chart. Okay, so this is pretty amazing and pretty awesome. Actually, it will saves a lot of time, and you can do a lot of other tasks as well while your deep learning model gets trained. So this is a very innovative project by Clean Pegasus, as you can see here. This is the GitHub repository of Tensordash application. So most probably to install this, you have to follow this entire documentation. I'll provide you the link in my description as well. So just you have to do just open your terminal or command prompt and just type a sudo pip install Tensordash. For Windows users, just do a pip install Tensordash. Okay, if you're using a virtual environment, so sudo is not needed, just do a pip install Tensordash. So after that, what you have to do is you just do a git clone of this entire repository. Okay, where the setup.py file is there, so you have to run that file mainly. So you have to git clone this. If you don't have git installed, just install the git, or just download the zip file and put it in a memory location and just unzip it. So yeah, after that you have to do this cd Tensordash to go inside the Tensordash folder, and there you can find this setup.py file which you have to install. So just put this command. If you are a Windows user, just do a python setup.py install, and if you are using a Linux or Mac, then you can do a sudo here. And if you are using a virtual environment, so just do a python setup.py install. So this will probably install it into your system. So after that, what you have to do is you have to install this Android application. So let's go to the app Android, and if you go into the Play Store, just type Tensordash and you can see this application here. Okay, I have already downloaded it and installed it. Please install it in your system, and after installing it, it will ask you for username and password. Using that, you can connect using with your system. Okay, I'll show you to do that as well. So let's go to our code. Okay, so here you can see that let's try a simple example like customer churn prediction. So what is churn prediction? Churn prediction is a customer attrition. It occurs when customers stop like doing their business with a company. So this is just a binary classification task, and here we can see a column called exited. Okay, so this is just a 1010 thing. Okay, so this is a binary classification task that a person has stopped doing a business or he's still doing a business, so it's 1 on 0. So just separate and x and y, just find out which are the categorical features, find out which are numerical features, do pre-processing on them, and all those things. Okay, this is a simple data set, so just get dummies on these two um, categorical variables. Okay, and just we are doing a one-hot encoding here. So and here just concatenating it to our original data set. Okay, and just dropping the unnecessary features. So similarly, just do this, like split it into train and test, then do a standard scaler. Okay, and just beware of the data leak, because it is always beneficial to do a split and then you do a scaling operations. Okay, and because there is something called mean and standard deviation involved in it, so it can leak your test data or train data as well. So it's okay. So as we can see that we have done a standard scaling, we have done a standardization of this model, and you can see the values here. After that, what you will do is, as here you can see the TensorFlow version is 2.0 in my system. Not upgraded it yet, but we'll do it in future. So here we can see that this is our model, and this is a two layered, two hidden layer neural network MLP structure. Okay, so and a one unit at the last, because we are doing a binary classification with sigmoid. Okay, and we can see that kernel initializes global uniform, and we know that the global uniform works well with sigmoid. And yeah, and the he uniform, like he normal, he uniform, this works better with ReLU. So this is our network, as you can see, and this is what is required. Okay, so let's try this. So model 1. Okay, so we are using this email. You can use any model name here. Okay, as you can see, if you go to the AirDroid, you can see, I'm sorry, some other application has opened. Okay, so if you go to the AirDroid, and you can see here, okay, this is a Tensordash example, this is alien example, this is a subject or a topic you can select. So I have selected this as my model like name, and this is the email that you have to provide, and you have to provide the same email here, like the same email which you will probably be setting up while you set up your Android application. So it will ask you for your email as well as your password. So same thing, you have to run this code. It will ask you for a password, the same password which you have set in your Android application, Tensordash. So most probably it is connected, and we will be running it for say 15 epoch speed, because we make it videos really fast. And we are I must tell you this, we are running this on a CPU and not a GPU, so it will take a lot of time if we run it on lakhs of epochs. So just running it on 15 epochs, since the data is also small, it is running this fast. As you can see, we can see the accuracies here, and also we can monitor the same in our application as well. See, so model 1 running epoch 1, this is the accuracy here. Okay, if you refresh this, yeah, see, epoch 15, this is completed, and this is 86% accuracy which you have got. So pretty amazing. If we go inside this, then we can see that this is a loss chart. This is the accuracy, which is okay, so nice. A little bit here and there, but if we increase the epochs, this is the chart you just never want to get. Anyways, if you just increase the epochs, you'll get a better result most probably. So yeah, this is what this application is capable of, and this is really amazing. Like it gets your work done, and you don't have to sit in front of a computer, like waiting for your model to train, like when it will finish and all, and you can proceed with other applications as well, like for proceed with others, like the later steps of this after training. So this is really amazing, and hats off to the clean Pegasus, and for developing this application. So yeah, this is all for this video. So if you like this video, please like, comment, share with your friends, so that this information is not only kept within you. Just share it with your friends so that they also can use this, can exploit this application. Okay. And please subscribe to my channel if you like this video as well. And if you have not already subscribed, please subscribe, and most important, share this video with your friends. Thank you. Bye bye.